In this tutorial, we will learn how to create an interactive math game in SimLab Composer. The basic concept of the game is that the user will be presented with a simple math equation and must figure out the correct answer. The user will then shoot the answer at a rotating wheel displayed in the scene. The wheel displays numbers from 1 to 20, and we will ensure that the answer to each equation falls within this range. As the wheel rotates, the user will aim a gun and shoot at the correct number. The first step is to create the wheel's rotation. In the object tree on the left, select the assembly named Wheel Front. Then, click on the Animation tab in the bottom panel. With the current frame set to 0, click the Capture Keyframe button. Next, move the keyframe to frame 250 and rotate the wheel front 120 degrees clockwise. Then, set the keyframe to frame 500 and rotate the wheel another 120 degrees in the same direction. Finally, move to frame 750 and rotate the wheel an additional 120 degrees to complete the rotation. Now, if you play the animation, you'll see that the wheel front rotates 360 degrees and returns to its initial position, making it ready to be played in a continuous loop. To use the animation in VR, we first need to store it as an animation sequence. Select the keyframes you just created and click on Create Animation Sequence. Enter a name for the sequence and click OK. Next, open the Training Builder from the top toolbar. Since we want the wheel to start spinning at the beginning of the VR experience, we'll use the Scene Start event. Add a Scene Start event to the diagram, then attach a play sequence response to it. Go to the Sequences tab in the bottom panel and select the animation sequence you created. Attach it to the play animation response, then connect the event to the response. Make sure to set the loop option to true, as we want the wheel to spin continuously. Press Ctrl and Enter on your keyboard, then select Desktop Mode to run the VR experience. Since we haven't established a starting position, SimLab Composer has automatically placed one for us and is requesting confirmation of its location. Close the Training Builder and move the starting position to your preferred location. For this tutorial, I will place it in front of the panel visible in the scene. Click the check mark to confirm the position, and the VR experience will start. Now that the wheel is spinning as intended, we will move on to the next part, which is to equip the gun to the user, as if they are carrying it. Close the VR viewer and return to SimLab Composer. To equip the gun, we want the user to trigger the gun on the stand, which will then quickly be placed near the user's face, similar to the usual visuals seen in shooting games. To achieve this in the simplest way possible, we will set the gun as a HUD or a heads-up display element. First, select the gun and press Ctrl and C on your keyboard to copy it. Rename the original to gun stand and the copied gun to gun equipped. Next, we need to position the gun-equipped object near the user's face. Go to the Interactions menu and select Add User Gadgets. Select HUD and notice that a screen has appeared near the user's face. This guiding screen represents the user's full field of vision. Any objects placed on this plane will appear up close to the user, allowing them to easily see and interact with them. With the gun equipped selected, press N on your keyboard to activate snapping, then click on the HUD plane. Reposition the gun to make it appear on the right side of the user and slightly towards the bottom. Feel free to scale it down slightly if needed. Click the Add button in the HUD dialog to add the object. A confirmation message will appear, requesting you to position the gun as you intend for it to appear. Since we have already positioned the gun, you can proceed by clicking the check mark. Notice that there is a star next to the added item's name. This star indicates that the object will appear at the beginning of the VR experience. Since we want the gun to appear only after the user clicks on the gun on the stand, select the gun from the HUD dialog and click the star button to toggle this feature off. Close the HUD dialog, and let's move on to the interaction component of equipping the gun. Select the gun on the stand and press Ctrl and B on your keyboard to open the training builder. Add a node-triggered event and attach the gun stand object to it. We want the gun that has been triggered to disappear first and be replaced with the equipped gun, so we will add a hide and show response and attach the gun stand to the response. Make sure the show option is set to false, then attach this response to the node-triggered event. Next, we want the event to also make the equipped gun appear. To do this, go to the Users tab under Responses in the Dynamic Training Builder and add the Equipped to User response. Now, select the HUD gun and ensure you select the assembly with the HUD icon in the object tree. Attach it to the Equipped to User response, making sure to set the Equip option to True. Then, attach this response to the previous response node. Run the VR experience to test your progress. Next, we will begin implementing the firing system. Go back to SimLab Composer, and the first step is to create a bullet. From the Create menu, select Shapes, then choose Draw by Dimensions to create a sphere. A sphere will be created at the center of the scene. The first step is to ensure that the local transforms of the sphere are set to 0, allowing it to match its parent's transforms. This will produce accurate results when we later animate the bullet. Next, select the sphere assembly and rename it to Bullet. Scale it down and position it inside the gun's barrel. Next, we will create an event node that allows the bullet to fly towards the point where the user clicks or triggers the wheel. Open the Training Builder. Instead of creating a node-triggered event like we did for picking up the gun, we will use a trigger with location event. To access this more advanced node and similar options, right-click in an empty area in the diagram, go to Events, then Scene Nodes, and select Triggered, followed by with Location. This node not only enables triggering an object, but also provides the exact coordinates where the user triggered in 3D space. We will use these coordinates to guide the bullet's path. Select the entire wheel assembly and attach it to the event. To animate the bullet, go to the Object's Behavior tab under Responses and select Set Location. From the object tree on the left, select the bullet we created earlier and attach it to the response. Next, attach the Execute channel to the event, along with the X, Y, and Z channels, since we want the bullet to be placed at the exact location where the user clicked. Now, run the VR experience. Notice a few things. Once you move in the VR experience, the bullet remains floating in place, and when you click anywhere on the wheel, the bullet moves slowly toward it. With consecutive triggers, the bullets move from their previous locations to the new ones instead of flying from their original position inside the gun. Additionally, the wheel is highlighted with each trigger, which is not the desired behavior in a shooting game. Let's go back to SimLab Composer to address these issues. The first issue to tackle is ensuring that the bullet leaves the gun each time we fire. To do this, we will first ensure that the bullet's size and location fit the barrel, and then we will make a copy of that bullet. Rename the copied bullet to Bullet Reset. Next, select the equipped gun from the 3D area to reveal it in the object tree. Under the HUD assembly named Gun Equipped, drag and drop the Bullet Reset assembly to make it a part of it. This will ensure that the Bullet Reset assembly moves with the gun whenever it moves. Now the idea is to set the location of the bullet assembly to match the Bullet Reset assembly before it flies towards the wheel, giving it the appearance of flying from the gun's barrel. Go to the Training Builder and create a Get Node Location response, attaching the Bullet Reset assembly to it. Then, attach this response to the event. Next, create a Set Node Position response and attach the bullet assembly to it. Connect the Execute, X, Y, and Z channels to the Bullet Reset response, ensuring that you set the duration to 0, as we want it to be instantly placed back within the gun. What we have now is a system where, once the user clicks on the wheel, the coordinates of the Bullet Reset assembly, which is within the gun, are captured. These coordinates are then passed to the real bullet, allowing it to fly toward its target on the wheel. All that is left is to connect the set location nodes sequentially and reduce the flying time from 2 seconds to about 0.1 seconds. Close the Training Builder, and let's finalize the bullet's appearance by changing its material to an emitter material. Then, select the bullet within the gun and modify its alpha to 0 to make it invisible. Now, as you can see, once the wheel is triggered, a bullet will fly from the gun toward the location you targeted. The final step for the bullet is to ensure that it is invisible at the start of the VR experience. Once it has been shot, it should appear and then fly toward the target. Select the bullet from the object tree and press H on the keyboard to hide it. In the Training Builder, after the node that resets the bullet to its initial location, add a Show and Hide response and attach the bullet to it. Ensure that the Show option is set to True and connect it to the previous response. Then, connect the Show and Hide response to the Set Location node that follows it. To make the bullet invisible again once it hits the wheel, add another Hide and Show response with the bullet attached to it. Attach this response after the one that moves the bullet to the wheel. Since the flying time of the bullet is 0.1 seconds, you need to add a 0.1 second delay before making the bullet invisible again. Insert a delay response of 0.1 seconds between the set location response and the show and hide response. Run the VR experience to see the results. To address the highlight issue, select Environment from the object tree and, in the VR tab on the right, disable highlights. Next, we will add a visual effect to indicate the collision of the bullet with the wheel. Go to the Visual Effects menu and create a spark. We will animate the spark and also use a set location response for it, so we need to create an additional level for its assembly to control it. Right-click the spark object in the object tree and select Add Parent. Rename the parent to Spark Location, then select the spark and ensure that its local transforms are all set to 0. To animate the spark, Go to the Animation tab and set the current frame to 0. Scale the spark down to a very small size, then click on Capture Keyframe. Next, click on the Hide Object button in the Animation tab to make the spark invisible at frame 0. Now, move to frame 1 or 2 and click the Show button to make the spark visible at that frame. Then, move the current time slider to frame 5 or 6 and scale up the spark. After that, move to frame 10, scale the spark down again as much as possible, and click the Hide button to hide the spark at the current frame. Now, if you were to play the animation, you will see that the spark appears tiny, grows larger, then shrinks again before disappearing, which is the desired behavior for a collision effect. Select the created keyframes and click the Create Animation Sequence button, then type a name for the sequence. Next, open the Training Builder. Similar to what we did for the bullet, we will utilize the coordinates where the user clicked to place the spark and play its animation. Copy the set location response used for the bullet and attach the spark location object to it. Connect it to the previous set location response, ensuring you connect the X, Y, and Z channels. Set its time to 0 so that it appears instantly at that location. Now, create a play sequence response and attach the spark animation sequence to it. Connect this response to the set location response that precedes it. Run the VR experience to see your progress. Now that we have completed the shooting part of the game, we will implement the mathematical component. We will present the user with a simple multiplication equation, providing the first number and the sum of the equation, and the user will need to figure out what the second number is. In the Training Builder, open the Variables list and create 3 variables. Name the first variable A, the second variable X, and the third variable B. Set their initial values to 0. Close the Variables list and create a Scene Start node, then go to the Numbers tab under Responses and click on Set Number Variable by Expression. Select variable A and attach it to the Scene Start event. In the expression window, we want to set the value of the variable A, and we want it to be a random value between 1 and 20, so we are going to type math.random, open bracket, 1, 20, close bracket. This expression will give us a random value between 1 and 20. Now we need to create a random number for the variable X, which the user needs to solve for, so copy the response and keep the expression the same, and just change the variable to X and connect the response to the previous response. For variable B, we established that it is the result of multiplying A and X. To implement this, create a multiply response and attach the value of X to the first channel in the multiply node, and the value of A to the second channel. Connect the execute channel of the multiply response to the previous response. To store the result of the multiplication in variable B, create a set number variable response. Set the variable as B, connect it to the multiply response, and link the result from the multiply response to the value channel. Now that we have created the equation in the Training Builder, we need to present it to the user. To do this, we will use a variable writer and place these variable writers on the panel in front of the user. From the VR Effects and Media menu, select Variable Writer. Rotate the variable writer and position it to be aligned with the panel's surface. In the variable writer's properties to the right, set the variable to be A, and in the suffix field type, times ? And set its color to white. Copy the variable writer and move it to the right, and clear the suffix field, and set the variable to B, and in the prefix field type, equals. Let's run the VR experience and see what we have created so far. Looking at the panel, you'll see that variable A has been generated with a value of 4, accompanied by the suffix times ? And variable B displays the result of multiplying A and X, which is 52. Now, I'll reload the VR experience to demonstrate how the numbers are randomized with each run. Remember, both variable A and the invisible variable X will always have values less than 20. Now, we need to proceed with how the user will solve the equation by shooting the answers from the wheel. First, go back to SimLab Composer and you will notice that the wheel has thick glass covering all the numbers, leaving only 2 numbers visible at any given time. While the wheel is animating, only these 2 numbers are accessible, allowing the bullet to hit them. We'll utilize the bullet's collision with the numbers to validate whether the user has selected the correct answer. There are 20 numbers in total, and if you open the attributes section for each number, you will see an attribute named Numbers, which has a corresponding value. Each number is assigned a value ranging from 1 to 20. These attributes associated with the number plates on the wheel will enable us to verify which plate the user has shot at and determine if it is the correct answer to the equation. Open the Training Builder, and from the Object Interaction tab under Events, create a Node-Entered Node event. This event will trigger responses once the 2 objects attached to it collide or intersect. Next, go to the object tree and select the bullet. Attach it as Scene Node A. For Scene Node B, we can't attach all the plates directly since we wouldn't know which plate the bullet hit. Instead, we'll use a Scene Node query to connect multiple objects simultaneously based on their name or attribute. Add a Scene Node query and click on Edit. Set the first option to attribute name, and in the value field, type in numbers. Click Preview and notice that it has selected all the number plates on the wheel, as they all share an attribute named Numbers. Finally, connect the Scene Node query to the Node-Entered Node event. This event will now trigger whenever the bullet hits one of the 20 plates. Next, we need to identify which plate was hit. To accomplish this, we will use a getAttribute response. Start by navigating to the Attributes tab under Responses and select Get Node Attribute Number. Connect the Events Execute channel to this response. Then, link the Scene Node channel where the query is connected to the Scene Node channel in the response. This setup ensures that the information flows from the query to the event and then to the response. Finally, set the attribute name to Numbers. Now that we can identify which plate the user has hit with a bullet, we need to compare it to variable X to determine if the answer matches the presented equation. Start by going to the variables list and create a new variable named Target, setting its initial value to 0. Next, in the Training Builder, create a setNumber variable response. Select the target variable and connect the value from the previous response, which contains the number from the plate hit, to the values channel. Don't forget to connect the execute channel as well. Now, whenever a bullet strikes a plate, the value of that plate will be stored in the target variable. The next step is to compare the target variable to the previously generated variable x. To track the user's performance, we'll count how many times they provide the correct answer versus the wrong answer. This will allow us to provide feedback based on their accuracy in solving the equation. From the variables list, create 2 more variables and name them correct and wrong, setting their initial values to 0. Once you've done this, close the variables list and create a branch response, connecting it to the previous response. Open the expression field for the branch response, and from the operations, select is equal. In place of the default new variable 1, type target on the left side, and on the right side, type x. Next, add an increment number variable response and select the correct variable. Connect this response to the true channel of the branch response. Now, copy the increment number variable response and connect it to the false channel of the branch response, ensuring that you change the variable to wrong. What we have established so far is that once the bullet hits a plate, the number on that plate will be compared to x, which is part of the equation. If it matches, the variable named correct will increase by 1. If it does not match x, the variable named wrong will increase by 1. Now, close the training builder and let's create 2 variable writers to display the values of correct and wrong. Copy the existing variable writer, scale it down, and position it slightly upwards. In the properties of this variable writer, set the prefix field to correct, assign the variable to correct, and change its color to green. Next, copy the newly created variable writer and position it slightly to the right. Change its prefix to wrong, set the variable to wrong, and change its color to red. Run the VR experience. As you can see now that we have shot the wrong answer for the equation, the variable named wrong has increased by 1. The only remaining task is to ensure that the equation is generated multiple times throughout the VR experience, allowing the user to solve new equations each time they shoot. Open the training builder. Select all 4 responses that generate the A, X, and B variables, then press Ctrl and C, then Ctrl and V on the keyboard to copy them. Next, attach these responses to the bullet shooting event so that every time the user shoots a bullet, a new equation is generated. To ensure that the variables from the previous bullet shot are not the ones being evaluated, add a small delay before connecting it to the show and hide response. Run the VR experience. You can press F2 on the keyboard to maximize it. As you can see, whenever we shoot a bullet, we receive indicators for correct or wrong answers, and the equation changes accordingly. Notice that when we shoot the wheel and not the plates, the correct and wrong answer indicators do not change, but the equation itself still updates, creating a functional skip mechanism. The game we have created so far is excellent. However, I suggest adding a timer to limit how long the user can play, which would enhance the challenge. To implement a timer for the game, go to the training builder and open the variables list. Create a new variable named GameOn and set its initial value to 1. This variable will control the game state. As long as its value is 1, the game will continue, and the events will function, but if the value changes, the game will end, and the events will stop. Next, create a delay timer and set the duration for how long you want the game to last. For demonstration purposes, I'll set it to 20 seconds, but you should aim for 3 to 4 minutes, about 240 seconds, to provide a better gameplay experience. Now, connect the delay timer to the node system that allows the user to pick up the gun. This way, once the user grabs the gun, the timer will start. To finalize the timer implementation, create a setNumber variable node and select the GameOn variable. Since its initial value is set to 1, change it to 0 in this response and connect it to the delay node. Next, to ensure that the events are enabled while the value of GameOn is 1, create a watch Boolean expression node. Connect the output Boolean of this node to the enable channel on the node triggered event. In the expression field, type GameOn == 1. Now, as long as the GameOn variable is set to 1, the events will function. Once the delay timer runs out, the variable will change to 0, and the events will stop working. To enhance the user experience when the timer runs out, you can add a few responses, such as hiding the equation or showing a message to the user. Select the two variable writers that display the equation and add a parent node to them to control both with a single node. You can rename the parent node for clarity if you wish. Next, in the training builder, create a show and hide response and attach the newly created parent node to it. Connect this response after the delay timer, ensuring that it is set to false to hide the objects. This will effectively manage the visibility of the equation once the timer runs out. To show a message at the end of the game, the easiest way is to copy one of the existing variable writers and position it in the middle of the panel. In the properties to the right, set the prefix to game over and ensure that you delete the variable from the variable writer so that only the prefix is displayed. With the new variable writer selected, press H on the keyboard to hide it. In the training builder, add a hide and show response and attach the variable writer to it. Connect this response to the sequence of responses, setting its show option to true. Now, run the VR experience. Now, once the delay timer runs out, the gun will no longer fire, the equation will disappear, and a game over message will become visible for the user. This setup effectively creates a challenging gameplay experience, as players must solve equations within the specified time limit. To further enhance the experience, we can add audio cues to the interactions. In SimLab Composer, navigate to the Library tab and select Sounds. Here, you'll find various sounds to incorporate into the VR experience by dragging them into the scene, which can then be triggered in the training builder. Click on one of the sound items to play it. Drag a notification sound into the scene to create a sound element. We'll use this sound as a notification when the user gets a correct answer, so be sure to rename the sound node accordingly. Let's also add the horn sound to play it once the game is over. Open the training builder and go to the response that add the variable correct and create a play sound response. Attach the first sound to the node and then connect the node to the increment number variable response. Now go to the node systems where the game over message appear and attach the second sound node to it, then attach it to the response. To test things, I will copy one of the variable writers and set its variable to X so that we would know what the right answer is, for testing purposes only. Now, run the VR experience to see the final result and enjoy the interactive features you've added.